Dear students, in this video we will solve some problems related to the amplitude modulation. First one, the maximum and minimum amplitude of an AM are 6.65 volts and 0.95 volts respectively. Determine the modulation index. Given E maximum equals 6.65 volt, E minimum equals 0.95 volts. We know that the modulation index of amplitude modulated wave is M equals E maximum minus E minimum divided by E maximum plus E minimum. Therefore, that's equals 6.65 minus 0.95 divided by 6.65 minus plus 0.95, that's equals 5.7 divided by 7.6, that's equals 0.75. M equals, that means the modulation index of amplitude modulated wave M equals 0.75. Next problem. A carrier wave with an amplitude of 2 volts is modulated by a sine wave of amplitude 1 volt. Calculate the modulation index of AM and the percentage of modulation. In this, given EC equals 2 volts and the modulated by a sine wave of amplitude 1 volt, that means EM equals 1 volt. We know the modulation index in amplitude modulated wave is M equals EM by EC, that's equals EM equals 1, EC equals 2 volts, that's equals 0.5. And also you must calculate the percentage of modulation. The percentage of modulation equals 0.5 into 100%, that's equals 50%. 50%. Next. Next problem. A carrier of amplitude 10 volts is simultaneously modulated by 3 sine waves of amplitude 1 volt, 2 volt and 3 volt respectively. Calculate the modulation index of AM wave. Given EC equals 10 volt, E1 equals 1 volt, E2 equals 2 volt and E3 equals 3 volt. We have M1 equals E1 by EC, that's equals 0.1. M2 equals E2 by EC, that's equals 0.2, and M3 equals E3 by EC, that's equals 0.3. Therefore, the total modulation index, the total modulation index of AM wave, the total modulation of index of amplitude modulated wave is MT equals square root of M1 square plus M2 square plus M3 square, that's equals square root of 0.1 square plus 0.2 square plus 0.3 square. Answer is 0.374. The total modulation index of amplitude modulated wave is 0.374. Next. Next. A 600 kilohertz carrier of amplitude 3 volt is amplitude modulated by a 1 kilohertz sine wave of amplitude of 1.5 volts. Sketch the frequency spectrum of AM wave. Given EC equals 3 volts, that means EC equals 3 volts. Next, EM equals 1.5 volt, EM equals 1.5 sine wave of amplitude 1.5 volt. Next, sketch the frequency spectrum of AM wave. That means amplitude modulated by a 1 kilohertz. That means, and also high frequency amplitude is F frequency is FC equals 600 kilohertz and FM equals 1 kilohertz. We know that the modulation index M equals EM by EC. EM by EC, that's equals 0.5. EM by EC means EM 1.5, EC means 3 volts. EM by EC equals to EM by EC equals 0.5. One 1.3 divided by 3, 1 by 2, that's equals to 0.5. Next, the upper sideband frequency. The upper sideband frequency. The upper sideband frequency FUSB. You know that FUSB equals FC plus FM, that's equals 600 kilohertz into 10 raised to 3 plus 1 kilohertz into 10 raised to 3. That's equals 600 plus 1. I'm taking common kilo. That means 10 raised to 3 That's equals 601 kilohertz. FSB equals 601 kilohertz. Next, the lower sideband. The lower sideband frequency. The lower sideband frequency is FLSB. FLSB equals, you know the formula, FLSB equals FC minus FM. FC minus FM. That means 600 minus 1 kilo. I am taking the kilo common. Kilo. That's equals 599 kilohertz. 599 kilohertz. And also the amplitude of sideband components. The amplitude of sideband components is, you know, ELSB equals EUSB equals MEC by 2. That's equals 0.5 into 3 divided by 2. That's equals 0.75 volts. In frequency spectrum, you know, the frequency spectrum of amplitude modulated wave having two side bands. One is FC plus FM and FC minus FM. That means FC plus FM lower sideband and FC plus FM, FC plus FM upper sideband, and FC minus FM is a lower sideband. We know we have FC plus FM upper sideband frequency 601 kilohertz. 601 kilohertz. This is the FC plus FM. Next, the lower sideband frequency FLSB equals FC minus FM. That means 599 kilohertz. 599 kilohertz. That means FC minus FM. You know, the amplitude ELSB equals 0.75 volts. 0.75 volts means 1 means here 0.75 volts. MEC divided by 2. In amplitude modulated wave, we are having only two side bands. That means FC plus FM and FC minus FM. This is the frequency spectrum of AM wave. Next. Next problem. A carrier is amplitude modulated by a 2.5 kilohertz sine wave. Calculate the bandwidth of an AM wave. Solution. Given FM equals 2.5 kilohertz, we must calculate the bandwidth. We have the bandwidth of AM wave. That means in amplitude modulation, the bandwidth is that's equals to 2 FM. In amplitude modulation, the bandwidth is 2 FM. That's equals to, you know the FM equals to 2.5 kilohertz, 2.5 kilo. That means into 10 raised to 3. That's equals 5 kilohertz. Next, a 5 kilowatt carrier is amplitude modulated to a 80% level. Calculate the total power in amplitude modulated wave. That means given PC equals 5 kilowatt, given PC equals 5 kilowatt, M equals 80%. That means modulated, amplitude modulated to a 80% level. So M equals to 80%. That's equals to 0.8. We have the total power in amplitude modulated wave is given by PT equals PC into 1 plus M square, MA square divided by 2. Substitute value of PC and MA, we get 5K, 5K, 5 kilowatt into 1 plus 0.8 square divided by 2. That's equals 6.6 kilowatt. The total power is 6.6 kilowatt. Thank you.